Hello, geometers. This is a review of section 5. Wednesday, you hopefully watched that lecture. I better see my views going up or I'm not going to make any more of these. You're going to be doing textbook work. Anyways, you watched a video hopefully on similarity, the side splitter theorem, the triangle angle bisector theorem, and you had some problems to work on. I'm sending today the answers to those problems, and that's great. You look over what you did there, but there's always questions about 3 in particular. So I'm going to go through 3 of these problems. A couple things to remember first though. So everybody look over here. So numbers 1 to 3, this was the homework on page 448. Numbers 1 to 3 is that side splitter theorem. And the key thing about side splitter theorem, you have to look and see, are they parallel? The bottom of the triangle and then that thing down the middle. The segment that splits these sides. You got to have parallel. If so, then you can do the top over the bottom equals top over bottom. Okay, that's what numbers 1, 2, and 3 are. Then the next set was numbers 11 through 16, and those used the triangle angle bisector theorem. So I don't remember exactly how I worded it yesterday, but I think this kind of explains it a little better. Let me draw us a picture. So here's your triangle, and here's an angle of the triangle that has been bisected. How do you know it's bisected? Because you see these congruent marks there. You probably have to zoom in on that. Kind of small. So what the theorem says is that when you have the angle of a triangle bisected, then the opposite side, so if this is the angle, then go find the opposite side. It's this one right here. This is the opposite side of the angle. Well, that's what gets into the proportion. Those are the segments right here and right here that go into the proportion. So that's what I'm referring to as opposite bisect segment, and you put that over the adjacent side. You know adjacent means next to, so the side that is next to this little piece. Opposite bisect segment over the adjacent side. And so this one is adjacent of the squiggly line side. Okay, now, these triangles, this is how I drew them on our examples and in our notes, but they don't always have to look like that. You can have it turned sideways, okay? All right, so I'm going to do number 15, and that'll help you with number 14. And then 29 is another one that people sometimes get stuck on. You need to know about perimeter, and I know you know what it is, but we're gonna look at how excuse me, how it's used on that problem. And then the last one, 33. There's a square in it, x squared, and that's going to cause some of you to panic and freak out. You can do it though. I'm going to show you some stuff for that. All right, so here we go. Number 15. Look at it. The triangle angle bisector theorem. So I'm just going about my business, making a proportion. I need to do this over the adjacent equals. Now, I started with that on purpose because did you notice there's nothing here? So we need to figure out what that is. You don't just throw another letter in it. You don't just call it X. You don't guess what it is. Let's think about this. The whole thing is 10. Well, let's just say that this much of it is 2. How would you find this? You would do 10 minus 2, right? So you'd know, oh, it's 8. Let's do another. Let's just say that this piece here 7. Well, the whole thing is 10. So how would you find this? I know it's 3, but how did you get that? I'll tell you how you did. You did 10 minus whatever that number is. That's the key to number 15 and number 14. Okay, so now take this. Opposite segment bisector piece. Put it here. Over its adjacent side. And now you're good to go. You cross multiply. 6x equals, look at this. You see this? Be very careful of the distributive property. 6x equals 80 minus 8x. Let's add 8x to both sides. 14x equals 80. Get the calculator. 80 divided by 14, 5.7. Okay. Is that right? Oh, well, they left it in fraction form. This is what I did. 5.7. Okay. Number 29. So, let's look at what 29 is telling us. It says, excuse me, the perimeter of this triangular lot is 50. Okay. The surveyor's tape bisects the angle. Okay. Good to know. Bisect. So I know I'm going to use this theorem to set up my proportion. I can think of it kind of like a formula, you know? Okay. So here's the thing. 12 over x equals 8 over y. There's a problem here. Do you remember when we worked with systems and we said you can't have x and y in the same equation? That's what's going to happen here. So what I'm going to do is I'm going to rename this. I'm going to figure out, well, what would y be with respect to in relation with this x? Okay, so what is perimeter? I know it's 50, but what is it? Yeah, all the sides added up. So I've got 20 down here, right? 12 plus 8, 20. So that means I've got 30 meters left. Now, nowhere in here does it say that this is 15 and this is 15. It does not tell us they are equal. So let's do what we did up here. Let's just say these two have to add up and equal 30. Let's say this one was 10. How much is this? 20, yes. Okay, let's do another. Let's just say these two have to add up to 30. And this one is 7. So how much is this? Did you say 23? You're right. How'd you get 23? Oh, you did, let me move this. You did 30 minus whatever this one was. So now look, use this and this and this and this in your proportion. That's how you do this problem. So here we go. The angle's here, so this is my opposite side. 12 over adjacent equals 8 over this thing. It's all x's now. We can solve it. 8x equals, now look, be careful with the distributive property. 8x equals 360 minus 12x. Add 12x and it goes away. 8x plus 12x is 20x. Divide both sides. X equals 18 meters. Now the question, you know, a word problem, you got to go back, read it, make sure you've answered the questions. Find the lengths of x, did it, and y. Well, good thing we wrote this note to ourselves, what y equals 30 minus 18, 12 meters. So there's your two answers, okay? Okay, the last one that I want to do is number 33. Where am I going to put it? Let me move this a little bit that way. And let me erase my 12 meter answer. Put it right there. Okay, so here's number 33. So look at the picture and figure out what theorem is it. Go ahead, think about that. Oh, I see parallel. So it's the side splitter. Okay, here we go. Top over bottom equals top over bottom. Cross multiply. Now, I see a lot of binomials, so you might put some parentheses around all these. Go this way, it would look like x times x plus 1. Put your equals in the middle. And then this, x plus 6 times x minus 3. Okay, over here, just distribute. X squared plus x. But this, you know how you do this? Think back to Algebra 1. Binomial times a binomial. Anybody familiar with FOIL? First, outer, inner, last. The first with the first is x squared. The outside, negative 3x. The inside, positive 6x. The L, the last, negative 18. All right, so these two are going to combine. X squared plus x equals x squared. 6x minus 3x is positive 3x. Okay, now, usually when you have x squared in an equation, you have to use factoring to solve. And factoring directly relates back to FOIL. But look at this. If you had x squared on this side and this side, you got to get them together. So let's take this one and subtract x squared from both sides. This goes away. We did that on purpose. Oh, and this goes away. No need to panic. You know how to solve this. Okay? I'm going to subtract 3x from both sides. I know I get negative 2x. I know. But look. These negatives cancel out. Cancel, cancel. X equals 9. I think that's all we had to do. Yep, just find x. Okay? All right, so that's how you do those problems. Use my answer key to kind of work your way through if you got stuck on some of the others, and then work on the review worksheet that's also in this assignment. It's out there. I sent it to you. So work on that. Do not turn it in. The answers are attached so you can see how you're doing. The test is coming next week, probably Tuesday. I'll get back to you. Okay? See ya. Bye.